Hey guys, Mr. Bullock here. This AP Stat lesson is on examining some relationships with some explanatory variables and response variables. And so let's go ahead and take care of this. So if the heights of 99.7% of the American men are between 5 feet and 7 feet, what would be a good estimation of your standard deviation? All right, remember the 68, 95, 99.7 rule? The 68 stood for one standard deviation. 68% of the data is one standard deviation. The 95 part was two standard deviations, so 95% was within two standard deviations to the left and to the right of the mean. And then this 99.7 right here is within three standard deviations. So three standard deviations to the left and three standard deviations to the right gives me a total of 6 standard deviations. That's going to span from 5 feet to 7 feet, which is 24 inches, since these are all in inches. So I take 24 and divide it by 6 of those standard deviations, and I get each one to be about 4. All right, choice C. Okay, so let's go ahead. So this is examining some relationships and interpreting scatter plots. That's in the next lesson, you guys. That's not in this one. So we're just examining relationships between some variables. So when examining the relationship between two or more variables, you first ask the following. So what are the individuals? Okay, what are the variables and how are they measured? All right, and how are the variables quantitative or categorical? All right, so then next ask, do some of the variables help explain the cause changes in others, or help explain or cause the changes in others. Sorry, I don't even read my stuff here. So if they help explain, they're called explanatory, and if they don't, then they are called a response variable. So a response variable measures the outcome of the study. All right, and then an explanatory variable attempts to explain the observed outcome, so explains the responses. So for example, the more I eat, the heavier I get. How's that? So the more I eat would be explaining my weight, and so my explanatory variable would be how much I would eat, and my response variable would be how much I gain in weight. All right, so note response variable depends on the explanatory variable, and it's easiest to identify the explanatory and response variables when we actually set values of one variable in order to see how it affects the other. So how much how much food, how much weight of the food did I take in versus how much I gained weight. So setting values. So okay, so here's section C. It's noted that alcohol affects body temperature. It lowers it. I didn't know that, did you? So to research this, let's take a look at example 1 on page 122. And here it is right here. Alcohol has many effects on the body. One effect is a drop in body temperature. To study this effect, researchers give several different amounts of alcohol to mice. Poor little guys. Poor little drunk mice. Then measure the change in each of the mouse's body temperature in the 15 minutes after taking alcohol. So the amount of alcohol ends up being the explanatory variable, and the change in the body temperature is the response variable. So the body temperature is responding to the amount of alcohol, which is the explanatory. It's explaining the body temperature. Okay, see the difference? So when you don't see the values, don't set the values of either variable, but just observe both variables, there may or may not be explanatory and response variables. Whether there are depends on how you plan to use the data. So here's an example of that. So are SAT math and verbal scores linked? Okay, so here one could be, I'll show you where it can be an explanatory and response, and then once where it isn't. So this is example 3.2 on page 122. Jim, he wants to know the median SAT math and verbal scores in the 51 states, including District of Columbia, after relating to how they are related to each other. He doesn't think that either score explains or causes the other. Jim has two related variables, and neither is an explanatory variable, and neither is a response variable either. On the other hand, though, Julie, she looks at some data and she asks, can I predict a state's median SAT math score if I know the verbal score? So Julie's treating the verbal score as the explanatory to see what the response math score would be. Okay, so here Julie's using the explanatory and response, where Jim, he's not. They don't count for either one with him. Okay, so in example 3.1, alcohol actually causes a change in body temperature. So, but there's no cause and effect relationship between SAT math and verbal scores. In the second example. So because the scores are closely related, we can nonetheless use a state's SAT verbal score to predict its math score. Well, sort of. Anyways, can you guys see that sometimes some situations will create an explanatory and response variable, and sometimes they don't, and sometimes you can get both. You can be persuaded in both ways. Just be able to be able to persuade your reader that. Okay, so some of those answers are correct, and some are correct also, just they're opposite answers. Okay. Anyways, if you're in my stats class, that would be your homework assignment. Take care.